Turgeon here, bringing you physics from afar. Temperature, thermal physics. We're getting to a new concept today. It's another vocab term that I haven't really introduced to you yet. I might have mentioned it briefly. And in particular, if we look at the big questions for this entire unit, these are like the essential questions, the thought questions that we should have in the back of our mind during this entire time. We've talked a lot about the difference between these, and we've talked about how they are often confused. Now let's focus on a different concept, a different question that's going to bring up a new vocab term. If we take different materials and we heat them up, how do they respond? Now, I've heated up some objects in front of you. We've looked at metals, and you might be thinking about water. I alluded to how water was special. Today we're going to talk about how water is special. How does heat flow? That's a little more complicated. That's something we're going to keep in the back of our minds. The focus of today is this question in particular. It's focusing on different materials, and there's a particular property of those materials that I want to highlight. There's a word in German called Gedanken, and it means a thought experiment. We're going to do a thought experiment. Why do we have to do a thought experiment? It's actually really, really hard to measure heat. By the way, you're presumably taking notes now, so you would put today's date and the current entry number. I don't remember. It's 7782. This is not really an official entry here. This is. So you might say to yourself, well, it's easy. Just take some water and some oil and put them over a burner. But there's so many factors going on, including this property that I'm going to highlight today, that we actually can't very easily ensure that we're putting 100 joules of thermal energy into each sample. So we got to do a thought experiment. Water, oil, and molasses. Why did I pick those? I don't know. I was thinking about things you might find in your kitchen, although I haven't had molasses for a long time. And we're going to say we want this to be a good experiment, so we only want, think about this for a second, how many variables should we have in a good experiment? How many manipulating variables? We should have one. So the only variable I want is to say that the material is different. Let's say we're going to have 200 grams of each material. Yeah, we could think of it as 0.2 kilograms. We're going to add 100 joules, so I'm controlling that. So that's heat, right? Adding 100 joules of thermal energy is literally the same as saying the heat is 100 joules. So I answered the first question. We can say about the heat that they all received the same amount of heat. There was the same amount of heat flow into each. They all are going to start from the same temperature. That's another thing we kind of need to keep constant. So 20 degrees Celsius is convenient because, as you may recall, that's room temperature. And something interesting happens. I estimated these numbers, but you'll notice that materials respond differently for their final temperatures. Yeah, they all increased, but they increase at different rates. Go ahead and pause the video and write that down. Water in particular, notice it was more sluggish to change. It was more inert. It's hard to change the temperature of water. It's got a high degree of sluggishness. It's got a high degree of resistance to changing the temperature. I don't know if I looked up the numbers for oil and molasses or I just made them up. The point is, different substances respond differently to all the same factors. So we call this specific heat. Specific substances have a specific capacity to change the heat. So think about, we're going to show you all these blanks, and you'll have time to write all this down, and then we're going to fill in those blanks with some numbers. But what I'm getting at for part A is that I'm referring to that experiment, and we're adding and removing something, and something's going to change differently. Here's a definition. The lowercase c is literally the variable that is not degrees Celsius. That is the variable for specific heat. It's the amount of something, and it relates to 1 degree Celsius. There's a particular substance that has a high specific heat. So pause the video, think about those for a second. Here are your choices. We're going to throw these in here. Temperature, heat, and water. So different substances change heat. That doesn't make sense because you can't really say, like, you don't usually say that things change heat. What you usually say is things have heat that flows into them between substances, but the substance itself can't really change heat. It could change thermal energy, but they have additional removal of heat and they change temperature differently. So specific heat is about temperature and heat. It's about how they change temperature due to the heat. Specific heat is how much heat you need to change the temperature. Think about that. Water takes a lot of heat to change the temperature. Now, nobody's looking at you. Say that out loud. Pause the video. Just say it out loud. Water takes a lot of heat to change the temperature. Now, for sake of argument, somebody could say, well, how much of a temperature change? 100 degrees Celsius or 2 degrees Celsius or 0.05 degrees Celsius? Well, we need a frame of comparison. We need a frame of reference. And so we say 1 degree Celsius. Okay, so let's always say it's going to be by 1 degree Celsius. So we have all these different substances like aluminum and steel and water and air. We want to change the temperature by 1 degree Celsius. Think about that. It takes a certain amount of heat to do that. You have to pump heat into them to do that. Water has a wicked high specific heat. I'll be sharing a table with you. That's why if you go to the ocean, you're going to notice the oceans typically doesn't vary. If you're at the beach, it typically is cooler in the summer and warmer in the winter. And I just want to highlight property of the substance. So specific heat is a property of the substance. So mercury has a certain specific heat. So here's a table. Don't copy this all down. I'm going to share this with you at some point. Hopefully I don't forget to do that today. Technically, these are all new entries. So what does this number mean? So let's look at mercury. Okay, so when you look at this table, the units are joules per gram degree Celsius, which is weird. But if you look at this number for mercury, 140, what does that mean? 140 degrees Celsius? No, it means joules. 140 joules per something something. Okay, does it mean that, remember this, like when we talked about acceleration, we said that, you know, you have an acceleration of 3. What does that mean? It means meters per second for every second. So it's change in velocity for every second that passes. So if I say what does 3 mean, I can explain that number and then I understand what acceleration is. Similarly, we can understand what specific heat means if you can tell me what that means, and here's what it means. It means I've got some mercury. It's poisonous, so don't go trying this. I've got some mercury, and I need to say how much I've got. Okay, 1 kilogram of it. And I want to increase the temperature by 1 degree Celsius. Sorry, it's really annoying to put the degree symbol in Easy Teach. So I want to increase the temperature by 1 degree Celsius. Okay, it takes a certain, you have to do something. It takes a certain amount of something to achieve that. The something that I'm talking about is heat. It takes a certain amount of heat to achieve that. How much heat? Only 140 joules for mercury. It's a particularly low specific heat substance. Very easy, you could say, to change the temperature. Does not take a lot of heat flow to achieve. Doesn't take a lot of energy. Water, whoa, takes 4,000 something joules to raise 1 kilogram of the water's temperature. Now, I would love it if you even try to write that in your own words. Like you could say something like this. Well, I'll pause the video and then we can think about saying it in our own words. Say something like, okay, if you take some water and you want to increase the temperature, specifically, you have 1 kilogram of water and you only want to increase the temperature by 1 degree Celsius. You need a certain amount of heat. The amount of heat you need is 4,186 joules. That is a property of all water. Now, of course, you could get into a discussion about like how pure the water is and if it's distilled and stuff like that. I don't think that makes much of a difference. That's why the human body is so close to water, liquid water. Notice how it's interesting too that ice and steam have different specific heats. Though human body is composed mostly of water. Here's an equation, and I'm going to try to not to use a certain word, but a certain word that in physics shows a better understanding of what an equation is. We have these different variables. I want you to think about what these might mean. I'm not even going to use I'm not even going to go into the calculations with this yet. We'll do that together, but Q is equal to MC times triangle capital T. Please make this a capital T and not a lowercase t. Q is the heat flow, which we measure in calories or joules. That would be lowercase calories. Mass, of course, is kilograms, but if you're using calories, you want them to be in grams. Don't worry if you're a little confused, because this is going to make more sense when we actually use it. So don't worry if you don't understand this yet. But if you want an answer in joules, use kilograms. If you're given a substance in kilograms, give your answer in joules. If you're given substance in grams, give your answer in calories. Specific heat is calories per gram degree Celsius or joules per kilogram degree Celsius. That's specific heat. So you can see that the heat is related to the specific heat. So for a certain mass and a certain temperature, a high specific heat means a lot of heat. Makes sense. For a certain specific heat and a change in temperature, a lot of mass takes a lot of heat to change that temperature. Yeah. Change in temperature, Celsius degrees. This is one variable. This is not two separate variables. And the change in temperature, you could say if you have a certain mass and a certain specific heat, like 3 kilograms of steel, and you want to achieve a certain temperature change, that takes a certain amount of heat. And if you want more temperature change, it takes more heat. Makes sense. Specific heat is a critical concept. It's not the same thing as thermal energy. It's a property of a substance. This has been Physics from Afar.